where I was supposed to belong. I never knew what I was meant to do. I never made sense to me till I made sense to you. I never said the storm. I didn't walk in a castle. I never walked the moon. I never prayed a 16 chapel. I can't play the jobs. But baby, when I'm the school, I would dare say my masterpieces, nothing new here for you, babe. For you, babe. Girl, I swear your hands are making me feel. But not so never that coloring was sweet. If I wrote the song, it would be Georgia, and you'd be on my mind. The star and valley will stand the test of time. I never was silver spoon. I didn't grow up in a castle. I never walked the moon. I never paid a 16 chapel. I can't break jaws, but baby, when I was through, they say my masterpieces back in you, yeah. Look on you, I think you. So get up, baby. I wanna take my time, wanna take all night. So get in, move, darling. Wanna keep on working till I get there. Lick like silver spoon. I didn't go up in the castle. Never.
1 1 2 1. Hey, 1 2 1 1 1 2 1 2 3 4 1. Hey, 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 hey. Test. Good. I'll shut it off.
are going to explore. A total eclipse is one of the rarest and most spectacular events in nature. For the first time since 1925, Western
know what you're drinking. Take my hand to the dance floor. You can guess what I'm thinking. Yeah, I'm all yours tonight. Girl, you like the way you move with that champagne dress. Yeah, we can go on the right, but we can hit the back door and get. If you're in and out to hell with the talking, you say, if you're in it, fire out the shit. You ain't gotta tell me twice. I said, you ain't gotta tell me twice. You whisper close to her. Let's move it to where we can. When you're leaning close like that, keep on teasing that tension. Do you feel the way you're moving that champagne dress? Yeah, we can go in the right, but we can hit the back. If you're in and I need to hell with the talking, you say it all. If you're in the the shit, you ain't gotta tell me twice. Girl, you lighting up downtown. The way you're moving that champagne dress. Yeah, we can go another round, or we can hit the back door and dip. If you're in and I need to hell with the talking, you say it all with the thing lights. You ain't got shit. You ain't gotta tell me twice. Round to you. With a tie that we cannot break, with a night that we can't replace. I'm locked and found with you in a bed that we'll never make. It's a feeling we always chase. I could write a book about the things that you said to me on the pillow and the way you think and how you make me feel. You can fill my mind and move my body with the fiction fantasies that call us what it is. We don't pretend it's real. So, promise it to she'll call a break. We only have one thing but only play. Wonder so should I really yeah. In another time, in another place. I hate that you can make me feel so small. Can't stop myself from falling back into you. You get so close to me, you pull yourself away. Maybe we just need a saving from saving. I could write a book about the things that you said to me on the pillow and the way you're thinking, how you made me feel. You can feel my mind and move my body with the fiction fantasies. Just call this what it is. We don't pretend it's real. So, don't promise it's simply you play. When you feel like some was already really good times. What can we do? Like something special, but it never felt like love. I knew what we could be living in. It's just a new era and it looks a lot like love. You start me talking as you kiss me from above. So said to me, you gone. Time in another day. In the morning, I'm okay. Just fine in the afternoon. But by night, I think about you. Like an echo in my brain. I wonder if you hear it too. At night, I think about you. It's just madness. How love can lead you to sadness. I lay awake and imagine. And think about it. It's supposed to. Baby, sleeping without you just isn't. Trust me, I tried it 1,000 times. Think about you, too. Think of me, too. If I can't shake you off my mind, and I don't know what to do. Every night I think about you. When I close my eyes, every time I go to bed, your tongue still plays in my head. I'm foolish, you're being hypnotized. Everything used to be, letting go ain't that easy. It's just a madness. Here, then you're gone, it's like that. I know you can imagine. You think of me the way I think of you, baby. Every night I'm going crazy. And I think about you. It's you, baby, baby. I should have given it away. You can try to tell me that. Too. Can't shake you. It's my way. In the rain, show up at night. Cause baby, you know that I can still shine.
Mic check one, two.
Nothing's the same as getting you know, yeah. Miles Street, he can't get the crowd, and I can't hear a sound. But you just keep on running, your mouth. Walk on over there, without to get there. Oh yeah.
Mic check 1, 2, testing 1, 2, 3, 4. How's that level on that? You got me good there? 1, 2. Mic check 1, 2, testing 1, 2. Mic check 1, 2, testing 1, 2, 3, 4, 5, 6. Mic check 1, 2, testing 1, 2. Hey, hey. Mic check 1, 2, testing 1, 2. Mic check, check. Can you hear me? 1, 2.
This is a new microphone. We're testing the levels. This is normal speaking voice. Check, 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 testing. That's a good level, I think. Oh, that's a little loud. Maybe it's not. Check, check, check. How's it sound back in the way back? Good. Great. Off we go.
Two. Check. Check. 1 2 1 2. Check. 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 1 2 1 2.
First we took each other, then we took neon. The lights were ours and all the stars. That's what we thought. Young and wild forever, forever wild together. With now or never.
Fulfilling myself away. Gotta leave and start the hymn. The way you move, like I just wanna stay. What have I become? Looking through your phone now, oh now, love to it's just a game. What I have done, darling, all the numbers, oh yeah, I don't want my heart to break, baby. How did you sleep when you lied to me? All that shame and all that danger. I'm hoping that my love will keep you up tonight. Baby, how do you sleep when you lie to me? All the fear and all the share. I'm hoping that my love will keep you up tonight. Tell me, tell me. Oh no, how did I manage to lose me? I'm not this desperate, not this crazy. There's no way I'm stick around to find out. I don't know like that. I won't lose myself. I have done, darling, the numbers. Oh yes, I don't want my to break, baby. How do you sleep when you lie to me? All that shame and all that danger. I'm hoping that my love will keep you up tonight. Baby, how do you sleep when you lie to me? All that fear and all that pressure. I'm hoping that my love will keep tonight.
you. All the shops in London are closed, and I don't know where to go from here. No, I don't know where to go from here, but I know I'm a mess, I'm a mess. When we're not together, such a wreck, such a wreck. I hope it's not forever. See you again. I wish it would be till the end. But I'm a mess, I'm a mess. I'm a mess, I'm a mess.
Since that night, oh, she said I love you just one more time. I try to figure out how to make sure
You are free to be the moment you are tied just for it. Tied just for it. Closer to the earth, I hear your voice, it's in my ear, but you're calling. Yeah. I'm a mess when we're not together. Such a wreck, such a wreck. I hope it's not baby. Yeah, too much for me.
take me back. I know you were way too bright from the eye, hopeless, broken. Slowly wait for me. Sky from the sea. So cold as sun. Thoughts get broken. I don't wanna be alone. When someone let you know. I don't wanna be alone. But I can feel it take over. Take control. I love everything I know. Go
What the hell happened with you and me? Cause oh, ain't no loving no more. You ain't as cool as you used to be. Closer to the mirror than you are to me. I said, oh, had to show you that door. Someday I hope we will fix it, cause I ain't proud to try. Say hi to your friends, and if they ever ask you why, you know you gotta go up. Ain't sick of being in control. Talking like vision is cure. You always heat it up, turn it up. Come on, why you always gotta show up? It's all in the radio. You hear the sound radio. Turn it up, turn it up. Sexy stuff that you can't take back. How did you think that I would react? Cause you must be out of your mind. Look, how did we go straight from love to hate? Now it's so deep that we can't be mixed. I said, oh, we should give it some time. Someday I hope we can fix it, cause I ain't proud to try. Say hi to your friends, and if they ever ask you why, you know you gotta grow up. Ain't sick of being immature. Talking like this is pure. Always turn it up, turn it up, turn it up. Come on, why you always gotta show? It's out in the new radio. When you hear the sound of radio, you're gonna turn it up, turn it up. Like the hands go. Always turn it up, turn it up, turn it up. Come on, why you always gotta show? It's something in the new radio. The when you hear this on the radio, you're gonna turn it up, turn it up, turn it up. Cause it's all about you. All the time, and the lights go out, they alone, and we're getting light. At a time when we're holding back, when it's time, baby, we're holding hands. I don't wanna hide no more. We making love for granted. I don't wanna hide no more. If this is your answer, but here we go again. Here we go again. No time to begin. So it gets better out the grave. I got questions, got no clue. What do we? How do my time is up and begging home? What is the reason that you're holding on? I don't wanna hide no more. We taking love for granted. I don't wanna hide no more. If this is your answer, but here we go again. Here we go again. No time to begin. Oh, it just better off afraid. I wanna be the boy got me calling so so got me so. Oh, I don't wanna hide no more. We making love for granted. I don't wanna hide no more. If this is your answer, but here we go again. Here we go again. So stop thinking. Oh, it gets better I pray. I it's all. Oh,
Thought that there was more, so I walked out the door, set out on the path unwinding, aiming for the stars, but I wound up in the dark. Didn't know this road would be so lonely. Where do I go from here? What do I have to show for all of the wasted years? And I don't think I could take no more. I need a little but I'm down. Been wandering for too long now. Tired of living this life on my own. I traded just to come back home. Come back home. Take a step up on the open road, but all I feel is fear and trembling. Turning back around, I wanting to be found, but all the questions keep me guessing. Where do I go from here? And what do I have to show for all of the wasted years?
Folks, how's everybody doing today? Yay! Are you having fun so far at Eclipse-a-Palooza? Happy Eclipse Eve to all who celebrate, right? Tomorrow's the big day. Well, we are still aiming for a 10:30 start time for our featured guest. My name's Troy, and I thought, well, we're sitting here waiting instead of just listening to music, but I thought maybe we'd have a little bit of fun. How's that sound? All right. So we're going to watch a quick 9 to 10 minute video, and then we're going to have a little bit of silly fun with some liquid nitrogen. Ooh. Right? Yeah, it'll be fun, I promise. First, though, who out there in the audience has seen a solar eclipse before, either partial or total? A lot of you, fantastic. Okay, who's seen a total eclipse? A little fewer, right? Those of you that have seen a total eclipse, is it a little bit cooler than a partial? No, it's a lot cooler than a partial, isn't it? Even 99.99999% is nowhere near as cool as a total eclipse. Those pictures that you've seen floating around everywhere, all over TV, all over the media, that's nothing compared to what you're going to see tomorrow, folks, as long as those clouds stay out of the way, right? It's really, really cool. There are colors. You see greens, you see pinks. It's indescribable. I got the good fortune. I was living in Montana in 2017, and my family and I drove down to Thermopolis, Wyoming, and we got to see 53 whopping seconds of totality, and it was one of the most life-changing things that I've ever experienced. It's really, really cool, and you really can't describe it unless you see it. Once you see it tomorrow, if we can see it, you'll understand why those eclipse chasers do what they do. If I wasn't living here in Buffalo, we'd be traveling to Buffalo or Cleveland or somewhere to see this thing. It's that cool. You'll want to see it again and again and again. So the biggest thing of advice I can give you is, having been to a total eclipse area, again, remember, I was in Thermopolis, Wyoming, 2,500 people, and there were traffic jams for several hours in the middle of nowhere, Wyoming, after that total eclipse. So the biggest advice I can give for after the eclipse is to just be patient. Traffic is going to be backed up, so just don't be in a big hurry to get anywhere. If you're going to one of these events that are happening around town, try to stick around for a little bit. Find some stuff to do, because that's going to be a lot more fun than just sitting in your car waiting for that traffic to clear out. It's going to be like a Bills game letting out all over the entire city all at once in one big shebang. So be really patient. And if you aren't going, we're going to be closed here at the museum tomorrow. We won't be here, so don't come here. But don't worry. One of the reasons why we're closed is we've been trying to send the message that really one of the best places to view this is in your own front or backyard. There really isn't a bad place. As long as you have a clear view of the southwestern sky, you're going to be able to see this thing. And if you're home, then you don't have to deal with the traffic, right? But don't worry, even though we're not going to be here, it doesn't mean that we won't be with you. We're going to be out with our media partners on WBEN Radio. We're going to be on WIVB, Channel 4. We're going to be on Channel 2, WGRZ. And we're going to be not only broadcasting, but also streaming. They're going to stream a lot of these things, so you can take us with you on your phone. And we can lead you before, during, and after the eclipse, everything that's going on, and all the things that you need to do to fully soak it in and fully enjoy it. So, okay. We encourage you to join us in that fashion and just have a good, safe time. And to make sure that we can view the eclipse safely, we're going to watch that video that we have lined up for you. Our very own Sarah Jane that works here for the Society, partnership with WNED, we produce a series called Compact Science. And recently, because of the eclipse, we partnered again and put together a Compact Science episode all about the eclipse, what it's all about, what you might be able to expect. So let's take a look.
Time since 1925, Western New York will experience a total solar eclipse, an amazing celestial event where the light of the sun is completely blocked out by the moon. And we are in the path of totality. As a wise man once said, where would you rather be than right here, right now? In this episode of Compact Science, we are going to explore the science of eclipses. Civilizations throughout history have paid special attention to eclipses. The ancient Greeks believed that they were a sign that the gods were angry with humans and that the sun would abandon the earth. The word eclipse actually comes from the Greek word meaning abandonment. An eclipse played a role in the unification of the Haudenosaunee Confederacy and the development of the Great Law of Peace. For millennia, those brief minutes have also brought moments of brilliant discovery. Everything from learning about the laws of physics, the chemistry of the sun, and the size, shape, and distance of celestial bodies. To understand what an eclipse is, we have to look at our solar system. At the center is our sun. Our sun is a star, just like the ones we see in the night sky. There are planets circling a lot of those stars too, but that's another story. The sun is the biggest, most massive object in our solar system. It's a huge source of light and heat and has a strong gravitational pull. This helps keep all of the planets in orbit. An orbit is a curved path of a celestial object around another object. So planets orbit the sun. But there are other things that orbit the planets too. These are called moons. The Earth has one moon, but other planets have way more. Jupiter, for example, has at least 95 moons. We may not notice that we're constantly in motion, but we can tell by the way the sun moves in the sky and how the environment changes around us over the course of a year. Actually, we're on quite a ride. The Earth orbits around the sun at a speed of 67,100 miles per hour. That's the equivalent of traveling from London to New York in about 3 minutes. So, planets orbit around suns, and moons orbit around planets. Sometimes these celestial bodies block out the sun's light and cast shadows on one another. This is an eclipse. On Earth, we observe two main types of eclipses, lunar and solar. In the case of a lunar eclipse, the light from the sun, which usually bounces or reflects off the moon, is blocked out by the Earth itself. The Earth gets in between the sun and the moon. Solar eclipses occur when the moon blocks out the light from the sun. So the moon gets in between the sun and the Earth. Although the moon is much smaller than the sun, the moon is also much closer. The diameter of the moon is roughly 400 times smaller than the sun. But by amazing coincidence, it also happens to be about 400 times closer to the Earth. So, during a total solar eclipse, the two bodies are at just the right distances to make them appear to be the same size in our sky, like a cosmic optical illusion. Not every solar eclipse is a total solar eclipse. During a solar eclipse, the moon passes between the Earth and the sun and blocks all or part of the sun. The moon's orbit around the Earth is not quite circular. At times, it's closer to us than others. As a result, the moon's apparent size changes over time. We call the moon's closest point to Earth perigee, and its farthest point from Earth is apogee. During a total solar eclipse, the moon lines up perfectly, mostly blocking out the sun while near perigee. In a partial solar eclipse, the moon only blocks out part of the sun. And during an annular eclipse, the moon is near apogee, too far away from the Earth to completely block out the sun, but you still see a ring of light in the sky. Two shadows are cast during an eclipse. The first is called the umbra. It's the dark center of the eclipse shadow. It's the part of the shadow where all light is blocked. The larger partial shadow is called the penumbra. While the Earth rotates or spins on its axis, the moon's shadow travels along a path spanning hundreds of miles on the Earth's surface. The path of the moon's shadow is called the path of totality. During the eclipse, anyone within the path of totality will experience darkness for a few minutes while in the moon's umbral shadow. The closer you are to the center line of the umbra's path, the longer totality lasts. Weather permitting, people along the path of totality will see the sun's corona, or outer atmosphere, which is usually obscured by the bright face of the sun. Those outside the path of totality, in the penumbral shadow of the moon, will experience a partial solar eclipse, where only part of the sun is blocked out. The path of totality for the 2024 eclipse stretches across North America, from northern Mexico to northeast Canada. Depending on where you are, you can view the eclipse beginning anywhere from around noon to 4 p.m. Here in Buffalo, the celestial show begins at about 2:04 p.m., and we will reach totality at 3:18 p.m. Just before totality, we may see a feature called the diamond ring or Bailey's beads. These are the last sharp points of sunlight visible, shining through the valleys at the edge of the moon. If the skies are clear, Jupiter and Venus, the planets closest to the eclipsed sun, may be visible, as well as the sun's swirling atmosphere. But even if it's a cloudy day, this eclipse is still worth experiencing. For 3.5 minutes in the middle of the day, the sky will darken as if it were dawn or dusk. The temperature will drop, and you may even notice animals behaving differently. An eclipse is something you won't want to miss, but you must observe them safely. You never want to look directly at the sun, especially not at a solar eclipse. Protect your eyes at all times. The only safe way to look directly at the sun is through solar filters, such as eclipse glasses. Homemade filters or ordinary sunglasses, even very dark ones, are not safe for looking at the sun. Proper eclipse glasses are thousands of times darker than sunglasses. You can also look indirectly at the sun by watching the shadows or making a quick and easy pinhole projector. The only time it is safe to remove your eclipse glasses is during the few minutes of totality. Ever wonder why solar eclipses don't happen more often? Well, the Earth, moon, and sun don't line up perfectly every month because the moon's orbit is tilted by about 5 degrees compared to the Earth's orbit around the sun. Most of the time, the moon's shadow misses our planet. The true rarity of a total eclipse comes not from how often one takes place, but from the fact that each one is only visible from a tiny fraction of the Earth's surface, less than 1%. The path of the 2024 total eclipse only covers 0.5% of the Earth's surface. Scientists estimate that a random point on Earth either sees a total or an annular eclipse on average of every 140 years. This eclipse, like all eclipses, is a window into the workings of the universe. Eclipses had and still have a lot to teach us. We learned about the cosmic confluences that occur when the sun, moon, and Earth align. If you're interested in learning more, check out our Compact Science Viewer Challenge. We have a fun eclipse experiment that you can try at home that's all about perspective. Get all the instructions on our website and be sure to share back your results. I'm Sarah Jane Gomlak-Green, and you've been watching Compact Science. Until next time, stay curious.
Compact Science is funded in part by the Joy Family Foundation and the New York State Department of Education.
We're going to explore the science of eclipses. Eclipses. Sorry, I'm so sorry, but how's everyone doing? Eclipses! Okay.
Yay, Sarah Jane. Really fun and informative video, huh? All right, if we could ask everybody that just came in, if everybody could scoot toward the middle as tight as you can. If you have an empty seat or two between you and your neighbors, everybody get friendly, pretend we like each other, just so we can make sure we can get everybody else in that's continuing to kind of filter in. All right, well, eclipses are pretty cool, right? Eclipses are very cool, especially those total. We've already established that. Well, now we're going to talk about something else that's kind of cool. My buddy Mark over here is going to introduce us to the fun, wonderful world of liquid nitrogen. So I'm going to help Mark bring the table up here. Go grab a microphone. All right, Mark. Just grab a couple of things and then we'll get started. Ooh, there's the magic bottle.
So hello, everyone. All right. Hello. My name is Mark. I'm currently a physics student at the University of Buffalo. Do we have any physics lovers in the audience? Yeah, everyone should be clapping. Yes. Yes, we love physics. But with liquid nitrogen, it's basically like, well, I also call it liquid death, but also liquid air. So about 80% of this room right now is composed of pure nitrogen, which is element number 7 on the periodic table, I believe. But yeah, so not everyone has seen liquid nitrogen before. And because I like to keep my fingers for a little longer, I'm going to wear these very well insulated gloves that might cause me to start sweating, but it's always to be, at least my preference, better to be slightly warm than frozen dead, but to everyone their own.
Actually, you know what? I think we're ready to move
Alrighty.
on to the big thing.
Oh, you want to do the big thing?
Yeah, let's go ahead and move this table out of the way. We'll skip the little stuff and we'll skip to the big stuff. Does that sound good?
When it's filled nitrogen.
That sounds really good to me. All right, we'll just move this table out of the way. I'm going to grab these two buckets over here and dump the balloons out of there because we don't need those. Now, liquid nitrogen is pretty cool, and we're going to have a little fun with it. And the way we're going to have fun with it is to try to ward off something that could kind of ruin our day tomorrow. What are those things that float around in the sky? They're white, they're fluffy. Clouds. Do we like clouds tomorrow? No, clouds are the bad guy tomorrow. Well, those clouds in Buffalo, they really like attention, right? They're always, hey, look at me. Do you see me over here? We're like, we see you. We see you all the time. And the problem is we don't want to see them tomorrow because they could potentially cover up the really, really cool part and make all this kind of a bust. So what I thought we might do today for some silly fun is we're going to have a celebration for the clouds. Are you with me? All right. So we're going to try our best to make today all about clouds. Today is cloud day. We're going to go big. We're going to celebrate these things. We're going to make them feel really, really super special. So if they have their day today, maybe they'll get their fix and maybe they'll move out of the way so the sun and moon can have their day tomorrow. What do you think? Do you think it'll work? Well, honestly, it probably won't make a whole heck of a lot of a difference, but we're still going to have fun trying, right? Yeah. Well, Mark here is filling up our buckets with liquid nitrogen. And liquid nitrogen, as I said, is cool. In fact, it is very cool. It is super cool. 321 degrees below zero. We think it's cold when it gets down to freezing at 32 degrees above zero here in Buffalo, right? Well, liquid nitrogen is nitrogen gas that's compressed and super cooled down to that minus 320 degrees Fahrenheit. And actually right now you see steam because that liquid nitrogen is boiling at room temperature. Isn't that crazy? Wow, indeed. So we're filling these up. We're going to need to get about 3 or 4 inches. We have our handy dandy measuring sticks here. Looks like we're there on this one. And in a moment, once we get to the proper level, we're going to get a couple of pitchers full of really hot water. So what do you think is going to happen when we mix something that's really super cold and something that's really super hot? Boom! It won't be a loud explosion, but what's going to happen is the water is going to mix with that liquid nitrogen and it's going to instantly vaporize it into water vapor. And what are clouds made of, all you scientists? Water vapor. So we're going to end up making a big gigantic cloud right here in the auditorium. How cool does that sound? Yeah. It'll only last for a few seconds. It'll poof up in the air. It'll roll up the front of the stage. You're the splash zone right here in the front. But don't worry, if you get any myths, it's just water, completely and totally harmless. Nobody's going to get hurt at all, okay? All right, so Mark's bringing our water up now for the grand finale. Now, you have the most important part. We have to make these clouds feel really super special, right? So I need you to cheer and clap as loudly as you've ever cheered and clapped in your life to really make these clouds feel like something special is going on today. So hopefully they'll move out of our way tomorrow, all right? Well, while Mark's bringing our water up here, I'm going to get my safety equipment on. Even though I told you it's harmless, I'm not taking any chances. Just kidding, it's really harmless. We hope. This is the first time we've ever done this. No, I'm kidding about that too. We actually practiced this morning. It's a lot of fun. All right. So Mark's doing the finishing touches. Good. All right, I'll get mine. Mark will get his. Now, the last thing that we need is we need a countdown because astronauts love a good countdown, right? So if you're ready, count down with me in T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Cheer really loud. Woo! All right. I got so excited I broke my pitcher. Keep cheering. Woo! They love it. All right, if you want to grab the squeegee. All right, I told you it was cool, right? Now I have to keep from falling in the wet water up here. All right, well, now that we had a little fun, I think we're about ready for our special featured guest. And to introduce our special featured guest, I would like to introduce you to our president and CEO of the Buffalo Society of Natural Sciences, Gary Siddall.
Check, check. Well, the director of the Science Museum apparently can operate some technology, so that's a good sign. Well, we're so excited to have you all here today. Who's excited to meet an astronaut? Excellent. Well, it's a very special day and a very special week for all of us here in Western New York. And the Buffalo Museum of Science is so excited to be able to host the special presentation this afternoon. But before we turn things over, I wanted to welcome a few of our distinguished guests here today. We have State Senator Sean Ryan. A round of applause for the senator, please. We have the Buffalo Council Majority Leader, Leah Halton Pope, who's going to join me up on stage in just a moment. And we want to extend a warm welcome and reception to our other partners in elected office that have representatives here in the audience today. So without further ado, I would like to welcome the Buffalo Council Majority Leader to the stage to provide an introduction for our distinguished guests. So please, a round of applause for Leah Halton Pope.
Thank you, Gary. Good morning, everyone. Unfortunately, Majority Leader Crystal Peoples-Stokes, the big Majority Leader, wasn't able to attend. She's got a little budget thing to work through. So I get to introduce our special guest today. Jeremy Hansen was raised on a farm in Ontario, Canada, and he has been passionate about aerospace from an early age. His time in the cadets from the ages of 12 to 18 prepared him to enroll in the Royal Canadian Air Force, where he became a CF-18 fighter pilot in several squadrons. Colonel Hansen was selected as an astronaut candidate in May 2009 and got assigned on a mission as a mission specialist in the Artemis 2 mission in April 2023. He will become the first Canadian to ever venture to the moon. Ladies and gentlemen, Colonel Jeremy Hansen.
Good morning, everyone. It sounded like you were having fun in here when I walked up. Something happened. There was a countdown, and there's a big mess, and I feel like I missed something very, very cool. And I wish they left the little smoking cauldrons up here. That would have been fun. Really great to be with you this morning. It's been fun to be up here in this neck of the woods. I live in Houston, Texas, lived down there for a long time now, and coming back up here and just driving around just reminds me of my time on the farm near London. I mean, it's only a couple hours from here, so this just looks really and feels a lot like home. So it's nice to be here. And really nice of the moon to set up something spectacular for all of us tomorrow. It's going to block the sun, and we're going to experience something extraordinary here. Cloudy or not, it is still going to get dark, and it's going to be very unique, and we're going to have a cool experience. I have never seen a total solar eclipse. Who in the audience has seen one? Anybody in here? Wow, yeah, we got a few. But I'm super excited to experience this for ourselves. I hope we have good weather. But regardless, it'd be cool to see. But you know what it makes me think of? I think it's just kind of neat to reflect. Humans have been seeing this for a long, long time on this planet. And I wonder, over time, what they thought as they witnessed this. Now science has taught us what's going on, and we understand why this is happening. But then even today, we're still using the opportunity of the eclipse to do more science, to learn. Our scientists will be observing the sun. It's a very special opportunity where we can gather data that we can't gather the rest of the time. And so we're still learning, and humanity's been learning over time. This building we're in today celebrates that learning. And I want to share a little bit with you today about what NASA, Canadian Space Agency, and our other international partners are doing to further science and further humanity. As was mentioned, I was assigned to the Artemis 2 crew with my crewmates Reed Wiseman, Christina Cook, and Victor Glover. And the four of us are going to blast off on the Artemis 2 mission to fly around the moon as part of a campaign of Artemis missions to take humanity back to the surface of the moon, to do science there, to push the boundaries of innovation, and eventually get us to Mars. And it's been an extraordinary ride for me in just the last year of being assigned to this mission, and a real honor to be a part of an enormous team of people that are doing this. So it's called Artemis 2, means there was probably an Artemis 1, and that's true. Artemis 1 flew about a year and a half ago. It was an extraordinarily successful mission, and there were no humans on the capsule. This is a real picture from Artemis 1. This is the Orion capsule out beyond the moon, looking back at it. Extraordinary. The engineers are smart that they put cameras on the end of our solar arrays so we can take these selfie shots with the Orion vehicle, which is really neat, and take extraordinary photos like that. But if you want to do something like this, you got to be inspired. You got to set goals. You got to know what you want. And as a young Canadian, I was inspired by the fact that humans left our planet and walked on the moon. That was extraordinary to me. I saw it in Encyclopedia A. Encyclopedias were these books we used to have. So before computers, if we wanted to learn something, we had to go to a book. And the books were organized alphabetically. And if you're looking for A stuff, you went to the A encyclopedia. And I went to the A encyclopedia because I wanted to learn about airplanes. It had these really cool pictures in there of airplanes. And one day, by mistake, I flipped to Armstrong, first human to walk on the moon. I saw a picture like this. I was like, whoa, what? That's crazy. And so I changed my treehouse into a spaceship. I started exploring space in my imagination. I innocently set a goal that I would like to explore space one day. And then I did the most important thing. I shared that goal with other people. I told family, I told teachers, I told mentors over time. And when I look back, I realized I didn't accomplish this. What really happened was I knew where I was trying to get, and people helped me get there because they knew where I was trying to go. So the simple lesson is set goals and share them with other people, and you'll be amazed at what you can achieve. So people directed me, and they're like, you like flying? I wanted to be a pilot, so I joined the Royal Canadian Air Force, became a fighter pilot. I always had in the back of my mind that I would apply to be an astronaut if I was given the opportunity. And so in 2009, I was selected by the Canadian Space Agency. Yes, Canada does have a space program. It's tiny. That's my friend David St. Jacques, and we moved down to Houston, Texas, and we started training with the U.S. Astronaut Corps. And because Canada's space program is relatively small, this is how we do it. We have this partnership that we work together as an international collaboration. So I'm part of a corps of 4 Canadian astronauts, and we all work down in Houston, Texas. So this is Josh Kutrick on the left, hired in 2017. That's my friend David. We were hired together in 2009, and then Jenny Gibbons from 2017. And Jenny is actually backing me up on the Artemis 2 mission, so she's training to go on the mission as well in case I can't go. So obviously, I hope you've heard of the International Space Station. How many of you actually seen it in the night sky? Yeah, okay. Some of you have some work to do, all right? Next time I see you, if I ask you, you better raise your hand. If you haven't seen the International Space Station, you really ought to do it. You can look it up. You can just Google it. And when is the International Space Station going to pass over my town? And find a night that it's coming over. You won't miss it. It's the 3rd brightest object in the sky. It's Sun, Moon, International Space Station. It's that big. It's bright. You'll know it. And it's booting it. It's doing about 18,500 miles an hour. So you'll see it streaming across the sky. But it is really cool. And when you look up at it, there you just think there are 7 human beings up in that International Space Station, which is true of right now as we're chatting. They're up there racing around the planet, and that's our laboratory for learning. It's an extraordinary place, and we use it to do really cool stuff. But I think the most important thing that we've done with this is we've demonstrated to the world that we can collaborate, even with people we don't necessarily work well with on the planet. We've demonstrated that good people with good intentions, we can do extraordinary things. And, I have to acknowledge American leadership. It's extraordinary. It's clear that the United States could choose to do space on its own. There's no question. The United States went to the moon essentially on its own. The United States could decide to do the International Space Station on its own or the Artemis program on its own, but it intentionally decided to lead. And leaders make space for others to contribute their gifts. And that is what the United States has done for a country like Canada. That's why I'm going on Artemis 2, is because you put out the call to the people, the genius in Canada, and they said, well, we can do things. We can build amazing robotic systems to help you with your space station. And we built Canadarm. And so the United States is allowing us to bring our gifts to the table, which is extraordinary leadership, in my opinion. We're so proud of this thing, we put it on our $5 bill. And then Canadarm is the long robotic arm there. And then this part here is called Dexter. It's a 2-armed robot, and Dexter can do all sorts of crazy maintenance. So it can go up to a broken part on the space station, grab a hold of it, remove the bolts, go get a new part and put it in. We use the robotic arm just about every single day on the International Space Station to maintain it, to survey it, to capture visiting vehicles with cargo. So it's Canada's contribution to the program. International Space Station, sorry, I didn't translate this. This is in Canadian. It's 400 kilometers above the surface, but that's about 250 nautical miles. And on our mission, Artemis 2, we got to go around the moon, and it's closer to 250,000 miles. So it's 1,000 times further than the International Space Station. And I just wanted to give you some context to why, it's so much harder to go to the moon than the International Space Station. And like I said, our goal in Artemis is actually to get humans to Mars one day and back safely, looking for the round trip ticket, not the one way, the round trip. And Mars is another 1,000 times further than the moon. So this gets really, really challenging from a logistics point of view, from an energy point of view. And so we have a lot we have to figure out. And the next logical step is to send humans back to the moon. We want to explore the South Pole. We got lots of questions we want to answer from the science we learned from the Apollo missions. And so lots of cool things coming. So if you want to go 1,000 times further, then you need a bigger rocket. And we built the SLS rocket, Space Launch System. The Orion capsule is on the very top of this rocket. And this is what it looked like when it blasted off. Hang on, that's not loud enough. You got to turn it up. We need rocket loudness. So the IT folks, crank the volume. Gives me shivers. Next time that thing goes, I'm going to be riding on top of it. And it's going to be something. And I got to see Artemis 1 launch in person. It was extraordinary. If you see a rocket launch up close, it is an emotional experience. And you feel the rocket in your chest. It is just thumping away. It's beautiful to watch. It's a lot of power and a really extraordinary experience. For Artemis 2, our purpose is to test the capsule. So we're not landing on the moon. If we land on the moon, it's a bad day because we don't have a lunar lander. It's not ready yet. And so we wouldn't be coming home if we survived landing on the moon. We wouldn't have any way to get back home. But our job is to do testing of the capsule. So to make sure that it's ready to do everything we need Orion to do in the future. And so we have a special profile. So we'll take off from Florida. We'll go around the Earth once. That'll take about an hour and a half. And during that time, we'll do a quick checkout of the vehicle, make sure everything's working, solar arrays are generating power, cooling systems are working, the life support systems look like they're functioning, and that we think we can survive another day in space. Once we're convinced of that, we'll burn our engine again here, and we're going to go out in this really highly elliptical orbit. That means we're going to go really far away from Earth, about 38,000 miles from Earth. That's really far. Remember, the space station's at 250. We're going to go up to 38,000, and that'll take a day. And then we'll come zipping back in to 100 miles on the far side of Earth. And that's by design, because if we find a problem in our first day, then we can come home and survive, and then we can fix that. If everything looks good, we'll do what's called a translunar injection. We'll do that over here, and we'll fly out around the moon and come back and land in the Pacific. And that'll take about 9 days to do all that. This is the crew and I checking out our capsule. This was in the summer. It's a lot further along now, but this is what the Orion capsule looked like last summer. It's the actual one we'll ride in. Whoops, I clicked too fast. I'm going to go back. This is Victor and I in the simulator, just training away. This is how you operate the vehicle with these buttons and these screens. We've done some medical training as a crew because we're up there all alone. Something goes wrong, we can't just turn around and come back to Earth. We have to do the whole mission once we leave Earth. So for 8 days, we have any issues, it's just us. We can have support from the ground as long as we have radio communication, but there's some medical procedures that we would want to be able to help each other out with if we had an emergency. We do a lot of training simulations to get ready to go. So this is practicing a launch day. So we actually went to Florida, slept in the quarantine facility, got up, had breakfast, just like we will before launch. We got in our suits. We walked outside where all the press normally is and where our families will be. They set up a fake family for us. They do everything. NASA thinks of everything. We waved goodbye to our fake family. And then we drove out to the launch pad. We climbed up the launch pad tower, just no rocket. So it was a bit of a letdown, didn't get to go. But this is how we get ready. And that's just the crew. Everybody on the ground team, the huge ground team at Kennedy Space Center, they're drilling as well. They're practicing, and they're doing exactly what they're going to do in the launch day. And we have another one of these coming up in about a month. This is the crew. We're going through some survival training here. So strapping into the capsule, pretending we've landed somewhere where we weren't supposed to and we're on our own. And how are we going to get out of the capsule into life rafts and all that stuff. This is out in the Pacific Ocean. So if we land in the right spot, the United States Navy will be there in all their glory to come and rescue us. And this is us training with them and figuring out how they're going to get us out of the capsule. Once they get us in a raft, they pick us up in a helicopter. It's a really cool ride. First time I'd done that. That was fun. It's a type of fun. It's called type 2 fun. It's fun after. And this is the ship that comes to get us. It's an enormous ship. It's crazy that this huge ship comes to get us in this little capsule. But and then once they get us on board the ship, they pull the capsule inside this marine landing craft. And that's how we get home. Some other neat training that I've done. This is Jenny and I up in Labrador with Dr. Gordonzinski from Western University, and we're in a meteor crater here. Christina came with us as well. And this is a really unique place on Earth because it's primarily a northocite in this region. A northocite is a rock that is very prevalent on the moon, but not very common on Earth. And so in Labrador, we happen to have this rock type, and it happened to get hit by a meteor, which is cool. So we can see what these samples are going to look like on the moon in this special crater in Labrador. So it's a really unique opportunity to train for that. A northocite is sort of like a granite, if you can imagine that. So our goal is to start to develop the technologies that we will use on Mars or need on Mars. And so things like growing food on the moon is going to be important if we're eventually going to figure out the logistics train for going to Mars. Delivering healthcare remotely is going to be important if we're going to go on these longer trips. And so we plan to develop infrastructure on the moon, explore new places on the moon, a lot of really cool things coming up. As part of Canada's contribution to this Artemis program, no surprise, we decided to build a Canadarm. So Canadarm3 is a new generation of space robotics, but it is a huge challenge because you got to do things 1,000 times further and you have a comm delay, so you need more automation. And so this is a third generation of space robotics that we're building. And this is a picture of what's called Gateway. So the international partnership is building this small space station that will orbit the moon. And you can kind of think of it like a hub. So like in order for me to get here from Houston, I flew to Washington was my hub, and then I got another plane, flew to Buffalo. The Gateway is going to be like that. So the Gateway is meant to enable all sorts of things to happen, but commercial infrastructure, commercial landers, bringing science back to Earth. Astronauts will go here, they'll stage from here, and then they'll go down to the surface. So in the future, this will sort of become a hub for going to the moon and maybe potentially Mars one day. Now, if you want to get to the lunar surface, you need a lunar lander. Remember that from Apollo. The Apollo landers were really small. We are building 2 lunar landers right now with Blue Origin and SpaceX, but I just wanted to show you the SpaceX lunar lander because this concept is very bold and it's enormous. These are astronauts. This is just a drawing, but these are astronauts to show you the scale. That's like an RV-sized lunar rover coming down that elevator. And the reason I'm showing you the SpaceX one is because they're taking what's called a rapid iterative approach in their system. They're working closely with NASA to do this, but they have a concept, they build it, they fly it, they see what fails, and then they fix it and they try again. So when they try something, they don't expect it to succeed. And I think that's relevant to our personal lives as well. So in order for this whole thing to work, they actually have to be able to land it on the moon, but they also have to be able to land this Starship on Earth because it needs to be reusable, and they have to use it as like refueling tankers to go up and down. And mind you, this is just the top part of a much larger rocket, but this is them trying to figure out how they're going to land the Starship. This is a human underneath. Again, this is a real one. This is not a drawing. This is a real photo. So this is a huge piece of hardware. And in the video I'm going to show you, nobody gets hurt. There's nobody on these rockets, okay? Sometimes I forget to say that, and then people gasp, and I'm like, oh. All right, so here's them trying to figure out how to land Starship. Yeah, I think that is so cool. I love watching it every time. It's fun to watch rockets blow up as long as your friends aren't on them. And it's really cool when humanity achieves something that was seemingly impossible before. And that's what you witnessed. That was the first time they landed it, and that was a huge accomplishment. But the main point here is that this applies to you and I. We talked earlier about setting goals and sharing them with others, and that'll surround you with people who will help you. But if you set ambitious goals in life, if you try to do hard things, the only thing I can guarantee you is that you will face challenge and you will experience failures along the way. That is a common human experience. Every single one of us. You can kind of rack and stack them and you can compare them between people. Some look worse than others, but everybody has these failures along the way, and everybody feels devastated by them at times. And the people who are successful are the ones that are like, that is just part of life. I am like every other single person. And you contact your support network, you get help, and you move forward. Set goals, expect failure, use your support network, and you will achieve some incredible things. And that is how we are going to send humanity back to the moon, take more photos like this. The crew and I will fly around the far side of the moon on Artemis 2, and we will experience an Earthrise. That's pretty extraordinary. We will take images of this. You'll all be in it. And every human will be in that photo. Even the people on the space station will be in those photos. We'll send them back. And while Artemis 2 is not going to solve all the problems of the world, we have huge challenges that we have to face on the planet. We do hope for a moment that it'll be a reminder to humanity that we can do extraordinary things when we set big goals and we come together as a human race to create together. And that'll be what is on the mind of the Artemis 2 crew as we're looking at this from our capsule. So thank you. Thank you, everyone. So we have some time for questions. We're gonna run some mics around the audience, and yep.
All right, one more huge round of applause for astronaut Jeremy Hansen. Is anyone else feeling really small right now? Well, incredibly inspiring presentation. Thank you so much for making us stop here at the Buffalo Museum of Science. And you're right, we would love to take some questions from members of our audience. And I see a very eager hand right up front here.
I have the Lego model of the ISS, the space station.
Is the Lego model of the ISS. Very cool.
Yeah, I love it. So you love space. I love space too.
Is there a experience in your astronaut career that profoundly changed the way you think?
No, there's really not, but I love the question because how I think is constantly changing and evolving, but it's in little tiny steps. You know, it's not one thing that changes it. It's not a step function. And I think that's very human. But over time, you don't want to stay rigid in your thoughts either. You want experiences. I have such a rich life because of the opportunities like this. I travel around and meet people that I would never have met if I didn't have these opportunities, and all of them influence me. I've had some, really extraordinary interactions with indigenous culture in this job that I just did not have growing up. I wasn't, near, an Indian nation or a First Nations culture. I wasn't embedded in that. And as part of this job, as I travel around communities in Canada, I've been invited in with elders just to learn their perspectives, and then over time form these relationships. And then I have had this amazing gift where like an Anishinaabe leader invited me to go on a vision quest, for example, as part of my preparation to go on this journey around the moon. He explained to me that in that culture, it's important to take time to prepare yourself mentally for a big journey like this. And I thought that sounds amazing. And so I went into, traditional area, very sacred territory for that leader. And he prepared me. And then I spent 4 days fasting, no food or water. I didn't think you were supposed to do that, but I'm like, I'm going to trust you. So I went and I sat in the woods alone for 4 days with no food and water. And it was an extraordinary experience for me. And so these things, they do impact me, and they do change my perspective. And now through that relationship, an artist created a mission patch for the Canadian aspect of Artemis 2. And it is something beautiful for me. It incorporates the 7 sacred laws. It's just one indigenous perspective. It's just from one culture. It doesn't represent them all. But for me, it's very meaningful that they would give that gift to all of us, that they would share it with the rest of humanity so openly like that. All right.
We have another question over here.
Do you like enjoying being an astronaut?
I do. I love this job. It's an extraordinary job. And I'll tell you, what I really love most about it is the diversity of diversity of things I get to do. And so I love challenges like flying jets and the challenge of that. I love the operational challenge of learning to fly a spacecraft. I love working with a huge team of people that are in their areas of passion. Like, you should meet the people I work with. They love what they're doing. They are so fired up. And the harder it gets, the more fired up they get. And they just want to tackle problems. And that's a really amazing thing to watch from my perspective. So I do very much appreciate this job. And then eventually I get to go to space. Crazy. That's awesome.
Hi, my name is Melvin Jelks. How long do you guys sleep on when you guys go to space, since it's always dark out? Like, when do you know?
Yeah, that's really interesting. It's actually never dark for us. It'll almost never be dark for us because when we go around one side of the Earth, the opposite side of the Earth from the sun, when we're close to Earth, it will be dark for probably like 40 minutes. But then once we come out, we'll be in daylight. Most of our mission will be in daylight. We'll be in the shadow of the moon for a short period of time, maybe like 15, 20 minutes. But the rest of the time, we'll be in the blackness of space, but the sun will be shining very bright on our spacecraft the whole time. So, but we just will sleep according to our watches. And so we have a schedule that we'll complete. We have a lot of tests to do during those 9 days. We're going to do those, and then we'll get a full night's sleep, I hope. And we just have sleeping bags, and we'll be in this capsule. It's about the size of a minivan. You saw a picture of us strapped into it. Once we're in space, we don't need the seats anymore. We'll just be floating around, and we'll tie our sleeping bags off in different spots and just kind of sleep crisscrossed in the capsule and just float there.
What do you eat on the spaceship?
Yeah, what do we eat on a space trip? Well, we have a huge diversity of meal options. So what we did as a crew is we went to the food lab at NASA, and we had lunch there 4 days. Took 4 days to eat, like just to try like a little tiny taste of every single meal type. And when we just rated them, like I don't like that, I like this. And then you let them know what you like, and then they put together a healthy menu. So you may not get, it's like what mom gives you on your plate. You may not get everything you want, but you will get some of the stuff you like, and you will get a healthy, balanced meal. But we have things like shrimp cocktail, craft dinner, curries, pudding. We have all sorts of stuff.
So no Canadian bacon or
I love it. I love it. You can be part of the show. That's great. No Canadian bacon on this one.
how do you plant trees on the moon?
It would be amazing if we could plant trees on the moon. If we want to do that, we have to have an atmosphere for the trees. Do you know what do trees breathe in? We breathe in oxygen, right? What do trees breathe in?
Carbon.
Yeah, carbon dioxide. And so trees need to breathe just like you and I. So we'd have to build a special atmosphere for them. And then we could, kind of like we do on Earth, we could live with those trees because they'd be helping us, we'd be helping them, and we'd have a symbiotic relationship. But we'd have to build like a greenhouse that's pressurized to keep the air in.
Oh, okay.
Good job, guys.
Where do you get your water at space?
Where do we get our water? So on the Orion mission, so like the Artemis mission, Artemis 2, we have to bring all our water with us. And then we won't reuse it. We don't have that capability in that tiny capsule. We just drink the water, and then we'll just, dispose of the urine. But on the International Space Station, it's really interesting because we recycle almost all the water. And so we have a special system. We collect all the urine, we collect the humidity out of the air, we recycle that, and we drink the same water over and over and over again. We call it yesterday's coffee today. And it's really gross to think about, but it works, and it actually is very clean water.
Hi. At the top of the lecture, you mentioned that there's data we can collect only during a solar eclipse. What sort of data are we able to collect tomorrow?
Yeah, it's not my area of expertise, but I've listened to a few people talk about it. So when normally the sun is so bright and you have so much energy, like the way you can study something is by the energy emitted by it, right? You can either reflect energy off of it, or in the case of the sun, it's sending all that energy our way, obviously. But during the eclipse, it blocks out most of the energy. And so the very edges, you can kind of think of it like the sun's atmosphere, the corona, they call it. That becomes much more visible. You have these faint signals. They're typically very faint, and they're kind of blocked out by the noise of the sun. But during the eclipse, those will become the only signal arriving at Earth. And so they'll be able to collect data on these regions that they can't normally do. We do study the sun normally with like telescopes that have like a blocker for that region, but there is still a lot of noise in the signal. So the eclipse will be the best time. We have a special instrument on an airplane, a fancy airplane at NASA that will be flying along in the total eclipse and trying to collect data. That's just one. They're doing, I heard yesterday, they're doing some sounding rocket tests, I think out of Virginia. And so they're gonna collect some data of the ionosphere here on Earth before, during, and after totality, so that they can compare the differences, things like that. That's all I know. That's it.
Okay. Is there any indication of when we go to the moon, will the Chinese have to become our rivals there? Will there be will we have to deal with them, a competition, getting there first and that kind of thing? Are they the same plans to go to the same place we do and everything like that? Thanks.
Yeah, these are all future issues that will need to be addressed. You can tell by the way I talk about things, I firmly believe in collaboration is where we as a race need to get to, but that doesn't mean we're there right now, but that needs to be our consistent goal. So I never I never cement the future means competition. I hope the future means collaboration. But the best thing that you can do is just lead by example and charge forward with a collaboration, working together with positive ideals, and then have open arms to welcome others in.
What's your favorite thing that you see when you're in the space shuttle? Like what?
Yeah. I bet you could guess. And everybody says the same thing. The favorite, I haven't seen it because this will be my first space mission, but all my friends come back and the favorite thing they see is Earth. Earth is extraordinary. I'm really interested in Mars. I think Mars is fascinating. We have some crazy theories about Mars where we think there used to be lakes and rivers on Mars. Where did all this water go? Where did the atmosphere go? Could that happen to Earth? There's lots of cool things about Mars, and in its own right, it's very beautiful. But it's kind of a crappy planet because you could, like, if you live there, you would never go outside without a spacesuit. You would never feel the wind. You'd never go swimming. Earth is a really remarkable place. It's an extraordinary gem in the universe, certainly in our solar system. And so this is very special. And when astronauts leave planet Earth and they look back upon it, they are just blown away by its beauty. My friend Reed Wiseman, we're on the mission together. He was explaining it to me one day. He's like, he's like, before I went, I saw all the videos, all the photos. Like, our cameras are so good, and the stuff that we send back from the space station, they're extraordinary images. But he said, when you're there and you see it with your own eyes, it is just somehow different. When you float up to the window and you kind of see the whole Earth in your field of view, and then you narrow in on a spot, and then you look through the lens, like a telescopic lens of a camera, and it's amazing, the planet.
How do you get to the moon?
Yeah, I've been asking the same question because it's important. Important that I know that. You need a really big rocket and you got to fly really fast. So that rocket that you saw me in the launch earlier in the presentation, that Space Launch System, it's a very powerful rocket. And so when you fly to the moon, you got to be going 39 times the speed of sound to get there. And that's how fast we'll be going when we get home too. And so when we come racing back into Earth, we'll be going 39 times the speed of sound. And then we got to slow down using the Earth's atmosphere and a big plasma ball and lots of G forces pushing us into our seats and lots of rocking and rolling. It's going to be something. And then we'll slow down and parachutes will open and we'll land in the Pacific. So to get to the moon, go really fast, go the right way. We have a saying in the fighter pilot community: if you're not going the right way, don't go fast.
What were your reactions when you got elected to be in NASA?
Sorry, wave at me. Where did that question come from?
Right over here.
Oh, thanks. I was pretty excited. Yeah, it's a lifelong dream of mine to fly on a space mission like this. I know all the astronauts really well, but I know these other three that I'm flying with quite well. Reed and I were classmates. We started training as astronauts together in 2009, and then Victor and Christina started in the next class after ours, and so we sort of like were mentors for them for a little while, and so I've gotten to know them really well. And so I feel like I'm going on this cool mission around the moon with three best friends, with a huge team of people. And I was really excited about that. And then I kind of felt a bit humbled, if you know what I mean by that. It kind of makes you feel like, why do I get to do this thing? Why am I so lucky? It feels a little bit off. And then I felt proud. And I didn't feel proud it wasn't pride for myself, but I was just really proud of humanity. It's not like everything is fixed, but I think it's really cool. Canada is going to be the second country in the world to send a human into deep space. And it wasn't, it was, like I said before, it was courageous and bold American leadership that enabled that, but it wasn't a gift. Canadians earned that. And then I kind of reflected on the fact, like, how hard Canadians have worked over decades with a vision to be part of something bigger than themselves. And that made me really proud. and then proud that we can do it together as an international collaboration and set that example.
How many rockets are on the ship?
How many rockets? So on the Space Launch System, on that big rocket, we have 4 main engines, which are the same. They came off of the space shuttle. Like they've already flown many times on the space shuttle. So we have 4 of those. And then we have 2 solid rocket boosters, those big white ones on the side. That gets us off the planet. And then once we get about 200,000 feet, we'll get rid of those solids. Once we get into orbit, we'll get rid of the big tank in the middle. And then we have a smaller engine that will boost us up in that big orbit around Earth. So that's another engine. And then we'll get rid of that one. And then we have an engine on the back of our service module, just the very top of the rocket. And that is what will take us to the moon and back. And then we have little thrusters on our capsule for when we're re-entering the Earth's atmosphere and we need to fly home. So there's a lot of parts to the rocket.
What is the hardest part of your space training?
Well, the hardest part is, I would say, just how much stuff you have to learn and interact with. I can't remember it all. It's just a lot. And so the way we do it as astronauts is that we rely on a really amazing team of people. So let's say you were on our team, you would have an area of specialty. Oh, I got a big thumbs up there. That's great. Okay. We got a future NASA employee. I love it. You would have a specialty, and we would ask you to learn every single detail about one part of the spacecraft and to help us learn it. And then you would go to mission control and you would be there to support us when we're up in space. And so if we had a question, we could ask you. And so the hardest part is figuring out what do I need to remember and be able to do myself, and what can I call you for and get help with.
All right, we're up to our last question. You get the last one. Make it really good.
Ooh, no pressure.
When will there be missions for like maybe going to the moon during a solar or lunar eclipse?
Well, the International Space Station will be flying during this eclipse, and we were talking yesterday about whether if they'll get to see totality from the space station. And it looks like they will fly over the shadow to the point where they'll be able to see that shadow of the total eclipse. So we will have people from space observing that, or observing the effects of it, which would be kind of neat. But orbital mechanics is pretty hard, it turns out. So, to have spaceships like Star Trek, where you just kind of go around a planet whichever way you want to go, we're not quite there yet. We're pretty limited. When you leave Florida on a rocket, there's only certain trajectories that you can go on, and it's hard to map out the path of the solar totality with a rocket ship. It takes a lot of energy. We could do it, but it's going to be a while before we get there, I'd say.
All right, everyone, round of applause for Jeremy.
Thank you, everyone. And the message I really want to leave you with, the last thought, and I'll repeat it again so that it sticks. What we're trying to do here is set the example for folks. Set goals in your life. They don't have to be career goals. They can be 1-month goals, 6 months goals. They can be career goals if you want, but set goals. Know where you're trying to go. Share them with other people, and you'll see that it'll enable you to do some extraordinary things. Thank you very much, everyone.
Excellent. So, show of hands, who wants to be the next NASA astronaut? I imagine we have a few career changes in the room. Senator, I'm pleased your hand is down despite the tough budget season, so that's good to see. Well, at this time, what I'd like to do is welcome Don Elick to the stage. Don is here representing M&T Bank, and you'll notice that their logo is around the room, and it's not just because we love the color green. It's because M&T Bank has provided the necessary support to land this program in order to make sure that it's accessible for the students of the Buffalo Public School District. So I'm now going to turn it over to my friend, partner, and funder, Don Elick.
Thank you, Gary. And thank you for indulging me as I close out the program. I cannot believe I had to follow an astronaut and indoor clouds, no less. So I'm about to embark on my own epic failure at this moment. So my name is Don Elick. I'm with M&T Bank. I work in the M&T Charitable Foundation. And so I'd like to give another round of applause for Colonel Hansen and also the Buffalo Museum staff that put this together. So at M&T Bank, for months we've been working hard to provide resources to the community to celebrate this eclipse and also to provide educational opportunities around it. It's very important that we help to uplift our community, and through that is through exploration and education. So this is just one of the ways that M&T Bank helps to support the community, and through the bank's support, we were able to allow free admission to all Buffalo Public School students this weekend so that they could enjoy all of the NASA programming and this lecture today as well. We're very proud to partner with the Buffalo Museum of Science and Gary Sedal and his entire team. They are doing a great job, and it's this type of programming and this type of community engagement that we highly value for everyone. So as the eclipse excitement continues, I encourage you to immerse yourselves in this learning and exploration, and there's no better way to do it than spend your day today at the Museum of Science. And I encourage you to also take advantage of the special NASA subject expert programming that's available today as well. So enjoy, thank you very much, and have a good rest of your day.
All right. Thanks so much. Thanks everybody for joining us for our program this morning. We do have our first subject matter expert from NASA coming up. We're probably going to push that back a little bit beyond 11:30, just while we switch everything over, switch out our next presentation. So you're more than welcome to stick around for that, or you're also welcome to explore all the Eclipse-a-Palooza activities that we have going on. Thanks for joining us today. We'll be back with you.